I have about 10 minutes before I've got to pick a kiddo up from school. So I'm going to get as far as I can in that 10 minutes. All right, let me make sure this is there's the working pen. There's the working pen. Okay, and erase. Let's switch to a different color. Okay, so this one we have to solve for theta. So notice we're solving each equation for theta. So first thing I'm going to do is remember we treat the trig like it is a variable. So I'm going to start by subtracting 1 from both sides. So I'm going to subtract the 1 to the other side. That's going to give me -4 equals -8 sine of 2 theta. Then I'm going to take that -8 and divide it to both sides because it's being multiplied right now. So that this is a double negative, so it goes positive, and that reduces to 1/2, which equals 1/2 equals sine 2 theta. We know that the sine is the y value, so I need to look on my unit circle for every time the y value is equal to 1/2 and find the radian measure. So here it's 1/2, my radian measure is pi/6. And then I'm going to keep looking. My radian measure, or my y value right there is 1/2. My radian measure is 5 pi/6. That says 5 pi. We take whatever's inside the sine. So by doing that radian measure, that's doing the inverse operation on the sine. So that's why we were able to do that, and the sine goes away. So we're going to set the 2 theta equal to both of those. Then I need to get this 2 to the other side. So right now it's under multiplication, so we divide. But remember, dividing by 2 is the same as multiplying by 1/2. So I'm going to multiply both sides by 1/2. So we got theta equals, multiply across the top and across the bottom, pi/12. And theta equals, because these crossed out, 5 pi/12. All right, on this one it says find the exact value of each. On the problems I gave you, this piece of it was missing. There is more than one way to get there, and there's more than one way that we can get 13 pi/12, but these are the values I chose. These values will be on the test for you, so you don't need to worry about it, but the statement is going to look like this, because we need to know where this is and what quadrant that is in order to get our sign correct at the end. So let's first of all figure out exactly what quadrant that's in. If I think about this, I know that this is pi right here, and I know that that is, so if I was to write that out, it'd be 12 pi/12, meaning that 13 pi/12 has to be somewhere in quadrant 3. That means that if I'm getting a sign in quadrant 3, that my answer has to be negative. So I know my final answer is better be a negative number, okay? All right, so I am going to do my sum and difference formulas because I've got a sine and I've got 2 angles inside the sine. So that pattern is, I'm going to put my equals here, sine, cosine, cosine, sine. Sine, cosine, cosine, sine. For sine, we keep the operational symbol the same. For cosine, we change the operational symbol. And then I'm going to plop those angle measures in there. Sine of 5 pi/4, cosine of pi/6, cosine of 5 pi/4, sine of pi/6. You need to be careful because these things are being multiplied and this is the subtract here. I saw people making mistakes on that. All right, so we got multiply, multiply, and a subtract in between. So we're going to go to sine of 5 pi/4. So we're going to go to 5 pi/4, and we're going to look at the y value, which is -2/2. Then the cosine of pi/6. So we're going to look at the x value on pi/6, which is √3/2. Then we're going to look at cosine of 5 pi/4, which is the x value here. So -2/2. And then the sine of pi/6, which is the y value, so 1/2. All right. Then we're going to multiply across the top and across the bottom. So I have a 4 here, and we've got -6 on the top. And then in the denominator, I've got a 4, and we've got a negative times a negative is going to go positive there, actually, and square root of 2. And then, it's kind of hard to tell if our answer is negative, but it is. You put it all over one common denominator of 4, and you've got negative square root of 6 plus 2 plus square root of 2. That's going to end up being a negative answer because this number is actually bigger than this number. So we're fine on our answer that it's actually landing in the third quadrant. And that's the final answer right there. I wouldn't take it any further. You might see it written as 2 minus square root of 6 over 4. All right, looking at skill 3. So this one here, the indicator that you're doing double angle, because it just says find exact values, you have 2 times an angle in there. All right, so I'm going to find cosine of 2 theta, which is this here. Remember, your u is going to act like your theta, which means I have a choice of these 3 formulas. In this case, I know exactly what the sine is. So this formula right here has the sine in it. So I'm just going to use that formula. So I'm going to do 1 minus 2 sine squared. Instead of u, I'm going to use theta because that's what I've got. So you've got 1 minus 2. I know I've got to square whatever I'm putting in for the sine. And this is exactly what sine equals. So I take that and I plug it in. So negative 15 over 17. So now we've got 1 minus 2. I need to square that. So I've got 225 over 289. And then I got to multiply the 225 by 2. So 225 times 2 is 450 over 289. I am going to make that 289 over 289. And these numbers are insane and weird, so they probably won't be quite this ugly tomorrow. And then we're going to subtract that, 289 minus 450, and you get negative 161 over 289. All right, see if we can get one more in here. We got to write it as a single power of cosine. Those are the instructions that know you're doing power reducing. So I'm going to put it into this formula right here. So this 8 is a coefficient that lands in front. I am substituting in for this. And remember, this is your entire u value. So you've got 1 minus cosine of 2 times the u divided by 2. Well, the u I'm going to put in is 6x. This is a numerator. This is a denominator. Our fractions from like 4th grade, 5th grade tell us that I can take 2 and divide it into 8, which is 4. And then I'm going to multiply together the 2 and the 6, so I get 1 minus cosine of 12x. I don't need to distribute in. You could probably leave it like that. All right, half angle. So the half angle identities, it actually says in the instructions to use half angle, so that's how I know I am going to do that. So half angle. So I'm going to rewrite this so I can figure out an angle that is, I'm going to plug in here that's on the unit circle. So I've got tangent of 1/2. Hang on a sec, I got to yell at my son for a second. Okay, I'll be there in a minute. Put on your shoes. All right, so we're going to do 1/2, and then I'm going to take whatever my numerator is, which is pi. Now I need to figure out what my denominator is. So what times 2 equals 8? And that's 4. So this is the angle that we put into the formula. We're going to choose the tangent formula. So you get to choose between this one or this one. They're different formulas that are equivalent. I'm going to choose this one. So I've got 1 minus cosine. My u is the pi over 4. And then sine of pi over 4. All right, so, I missed my unit circle, didn't I? Didn't draw it on this page. So my pi over 4 is here. It's square root of 2 over 2 and square root of 2 over 2, right, at my angle measure pi over 4. So I'm going to do 1 minus square root of 2 over 2 and then square root of 2 over 2. I probably should rewrite the 1 as 2 over 2. And then I'm going to put this over one single denominator upstairs. So I've got 2 minus square root of 2 over 2. And then we've got square root of 2 over 2. Notice we can take the shortcut like we did last year and cancel those. So my final answer is 2 square root of 2 over square root of 2. You're probably not going to match what the answer key says because they will rationalize it. It's okay to leave it like this and not rationalize it. All right, so you have to come back for the last part because I have to go get a kid and pick him up from school.